What's going on, guys? This is Davis, and this is my first episode in a series that I'm making, documenting the process that I use to design a robot. This particular robot is going to be a spherical type. It rolls around, that sort of thing. And the first part that we have going on here is the engineering process. Enjoy. What's going on, guys? This is VoiceOver Davis here. Right now we're looking at the footage of me engineering that spherical robot. Basically we're engineering the shell and some of the systems behind it. It utilizes like a ringed design, I guess, for changing weight differentials, and that's what results in the movement of the robot. Right now we're going through and creating the project. Oh yeah, by the way, I should probably mention that this video is sped up by 150 times, I think? No, 250 times, my bad. So the first step in creating the shell is creating a half circle. I kind of messed up the first time around, making that half circle, but finally ended up making her. And then I offset it and bridge the two top connections so that there isn't any kind of I didn't want to make a shell, I wanted to make a hollow portion. Now we're going to revolve that 180 degrees around that center axis there. And now we've got a half circle shell. Now I'm going to create some kind of a support area for, I think this side is for a little, I don't know what to call it, but a little connector that I made that connects the actual shell portion to the rings with a bearing type apparatus that I made. It's just a little ledge. Then I go through and I make a little key that is, I think, 0.5 by 0.25, or 0.5 squared by 0.25 depth, so that it's halfway through so the actual connector, when it's 0.5 cubed, it'll actually connect in there correctly. Now I go through and mirror it, then I realize that's not what I wanted. Any good engineer, you'll see this coming up here in just a second, needs to realize the usefulness of Google, and that's one of my next spots, to figure out the dimensions for a NEMA 17 stepper motor. And I just chose this random one. Actually, I don't think this one had the information I needed, so I ended up going to a different site. There we go. I think, which one is it, the one that I ended up using? Either way. So I picked one and just basically designed a NEMA 17 stepper motor just based off whatever I found. I figured I'd go back through and adjust those dimensions to be whatever. I have one just sitting back in one of my tool shelves, but right now, like I said, I'm just making the dimensions for that stepper motor. It's kind of difficult in Inventor because, well, it's not really Inventor's fault, but it defaults to to inches, at least on mine, because I have it set that way. And all the stepper motor dimensions are in millimeters, so I have to go through and delete those units and retype them in. And Autodesk makes it kind of difficult to select the units because most of the time you're not going to be doing that. You're just going to be selecting the number. Making a little post. I don't actually make the keyway for the post. Most of that's just due to laziness. It's really not needed for this project. If you wanted to get that in depth, you probably could. I just didn't really see a point. Take a little sip of coffee here. Alright, now I'm going through and creating the little angle pieces, and these aren't measured or anything. I just kind of did it for aesthetics. Um, I did make 135 degree angle there, so it's going to be pretty close. It's at least symmetric. Now I'm going to go through and use the place tool to get that. Oh wait, no, I did make a little indent there. Okay, now I'm making the spot for the stepper motor to actually slot in. And then I just did the 42 millimeters divided by 2. Ignore those little pieces that are missing there. I ended up going back through and filling those in, but I wasn't really sure how I wanted to do that at the time, so I just skipped it. And now I'm going to use the Inventor assembly mechanics to join that. Flip it over. There we go. Perfect. Next part I make, I think it's the outer ring. And I screw it up here because I get confused and I decide that I want to try to make the little connector, and then I realize, oh wait, I need the rings first. And I get through a couple minutes of this. Before I realize, oh crap, hold on. And it's about this point where I'm like, or I was going to extrude that circle. I'm like, wait a second, I don't know how far to extrude it. What am I doing? And I already had used the name outer ring because I'm a moron, so I just put a space in there. Now I did have a little bit of issue with actually getting the circle to go into to move because it got locked down to that center that center snap point there. And I ended up messing around with it for a while, and then I decided, screw it, I'm just gonna redraw it, not snap to that center point. And I'm including all these errors in here just because it's good to understand that even the best engineers, I'm not claiming to be all that great of an engineer, I'm really not. I just do it in my spare time because I find it fun. But even the best engineers make mistakes. Constantly, lots and lots and lots of mistakes. So don't be ashamed by that when you start off, or if you start off, whatever you want to do. But it is just a fact of really anything, especially computers. You're gonna make mistakes. I try to move that lock point, but no such luck. So I think right around here is where I just say screw it and delete it. And then I draw it not against that snap point, and I can easily move it. And I decided 6.5 inches or whatever that is. Yeah, 6.5 is too much, so I'm going to scale it down, I think, to 6.25. Yeah, that's right. Then I extrude that symmetrically by 0.5 inches. And that's the outer ring structure done. Now I'm making this square here. I don't know if there's a better way to do this. There probably is. But I needed to make a offset plane, or sorry, a midplane, so that I can easily cut symmetrical holes on each side of the ring. Because really that's the best way I've found to do this portion. And then I just go through and and just extrude down and delete that square. You can see me snapping onto that midpoint there, making the slots for the motor and slots for the bearings. And you know, these dimensions aren't final. From what I remember in past projects, 0.3 was about the size of bearing, or about the size of the bearings I was using were. Probably should have looked that up, but again, those are easy dimensions to change. All you have to do is go back through and edit the sketch, and Autodesk will update the file so that you don't have to go back through and re-engineer it or whatever. It's really a simple thing. That's what I really enjoy about Autodesk, is its ease of how easily you can make changes to your projects, and it'll just be like, okay, let's just throw that in there and update. Creating the other two bearing holes, this one's easier because all I have to do is, I think I create a line there. Oh, maybe not. 0.3, okay. And then I just go through, cut through all. Now it's time for the inner ring. And I get confused here. I'm thinking, okay, well, I need to make a work plane here, but I really didn't. But I do it anyway. I guess making that excuse me, making that mid-plane makes it a heck of a lot easier for me. It doesn't really matter. I could have just extruded down that ½ inch and it would have been fine, but I just like the concept of asymmetrical extruding better, personally. And now I'm trying to figure out why it's not working correctly. It takes me a while to figure it out, but it's because I haven't actually created the object. Somehow I managed to look over that. So I think I go back here. Eventually I figure it out and just delete that sketch and do it right. Yeah, because you can see, I should have noticed this, but you can see that I'm in object mode, or in assembly mode, because all the other random pieces aren't grayed out. There we go. Now we're in object mode. Now I'm doing it correctly. Symmetric 0.5. And now I gotta go through and create those holes for the bearings. I think those are all the holes that I need on this portion of it anyway. And now I think I'm gonna start working on a bearing. And I've made more bearings than I'd care to admit, so they're not all that bad. Basically, this process that I use is my go-to anytime I need to make some sort of a bearing, and it's not designed to be functional. It's just designed to give the visual impression of a bearing. Otherwise, you would make a bearing in several different parts, but making those parts and then revolving them. So say you have instead of just one bearing object, you make the outer portion of the bearing, inner portion of the bearing, and then all of the ball bearings themselves as different parts. That's much more, from what I understand anyway, I would assume that that's much more difficult for Autodesk to keep up on the rendering with. So I just tend to say screw that and just make it all in one part, because I'm not going to try to actually make a bearing anyway. Screw that. I'll leave that to the professionals. But you can see that I kind of made that cut down through the center there. And now I'm going through making a mid-plane in the wrong spot. So I start a sketch, and I create a square in the end of there to make a mid-plane through that. You'll kind of see what I'm talking about here when I start the sketch. But this just makes it so much easier for making the bearing tracts. I don't really know if that's what you call them, but that's what I'm going to, so. And this square just decided to disappear. I couldn't really understand why. And I look around, try to figure out where the heck it went. Finish sketch, and I'm like, what the heck? I just say screw it and just draw it again. And I should also mention, most engineers won't do this, but myself anyway, I like to just kind of engineer just sitting on my chair. So I use a trackpad for all my engineering. So I've gotten pretty decent at it. I got to admit, I think most engineers would probably scoff at that fact, but I don't really care. It's just how I enjoy doing it. I don't do it in a professional atmosphere. I just do it because I enjoy the process and I enjoy being able to make things. And the next step of this, the next part, my 3D printer is kind of out of commission and it's not big enough to print this anyway, so it might be a while until we actually see an update to this project. But new 3D printer is in the budget. It's in the budget. I'm planning on getting one hopefully here in the next month or so. And my 3D printer would work. It would just be nearly impossible for me to get this a sphere broken up into small enough portions to be able to 3D print on my printer. So I think the end project would turn out a lot better if I just wait until I get a bigger printer. And plus my extruder's been having issues on my current printer, and I gotta look at that. So here I just go through and cut a little bit of that out because I realize the bearings are much longer than I need them to be. And then I go through, I undo that, create a midplane, extrude, mirror. I decided to wait on that. Now we're gonna, oh, I already did it. Okay, I didn't even see me hit click apply. Now I'm gonna go through, create a few different copies of that, and place them in their respective area, and screw it up royally. And this is a lesson you'll learn too, if you're planning on doing more or working more with isometric drawing utilities or whatever the hell they're called. At least this one, I realized that my rings were locked in place, right? They were. Let's see, I think I unchecked adaptive. And I didn't even know at the time if that was going to work, but it did. Let's go through, joint. I just accept the relationship. I think it's because the bearings are slightly smaller than the holes in the rings, which is totally fine. It makes for an easier assembly process, but either way, it's going to tell you that you're an idiot. I try to just place it in there. I don't with no such luck, so I just place it and then just join it. And I decided the easiest way to do this is to just place that in there. Can't really get it, so I around and I flip it. Oh, okay, I didn't flip it because I'm an idiot. Try it again. Select it. Place it. There we go. Perfect. And now I go through and I try to mirror it at first, then I realize that the rings aren't symmetric to the rest of the project. So that's not going to work, and you see those bearings just show up in the middle of nowhere. So I go through and I select the rings, and I set the XY plane to visible. And we go to mirror on the XY plane, and there we go. Easy placement of bearings. Next step is just to place those last couple bearings. Flip that. Perfect. Or last single bearing. I think that's it for the bearings. I don't even really remember what I'm doing here. Okay, I'm cutting down that little post there. I figure, in an actual assembly-based environment, I can go through and just chop part of the post off and regrind down the key if I have to, or I could also use threads. I have a threaded stepper motor, which I think actually would work better. Just some simple plastic threads would probably be fine. It's not like this is going to be a military robot or something. Coffee time. I really hope this microphone actually turns out with decent quality, because this is a relatively new microphone that I have. I haven't really done a whole lot with it. Just bought it kind of cheap off Amazon. Anyway, so now we're working on that little connector piece. And I will say that I'm probably going to go through and fillet. I don't know what they call it. Fillet? I don't know. See, I never really I don't have friends or anything that are engineers. I don't have anybody. It's just me. So whatever terminology I have is just whatever's, I don't know how to pronounce it. But anyway, going through and I'm creating the little the connectors for the rings between the bearings. You can kind of see my on the left side there in the component view. You can kind of see my naming system. It's actually kind of dumb. I should have picked something a little better, but it works. Really, oh, I'm creating a platform here for the actual electronics. Now, I will say that I have tried designing one of these in the past. It didn't go over all that well. Um, I spent so many hours trying to figure out how I can engineer this robot to fit within the constraints my printer had. I used tiny stepper motors, and it overall just did not work out all that well. I only had 5.5 inches, the sphere, so a 5.5 inch sphere to deal with for all of the electronics for the robot, including a Raspberry Pi. I think it was a standard vape cell battery. I don't really remember what it was called, what the numbers on it were, because I literally bought one of those little cheap, um, those cheap batteries at Walmart, and the rechargeable phone battery. But you know what I'm talking about. But I took and I just broke that in half, stole the cell out of there. Now you can kind of see that in that platform that I created, those slots there. Those are particularly for routing wires between the underside and the upper and underside of the inner ring, just simply because I understand that it's not going to be feasible for me to be able to route those wires through anywhere else. Um, so at this point, I think the robot's actually finished. I'm just going through kind of demonstrating what my plan with it is, how it's going to fit together, and then I go through and I render it in in the 3D print render. And that's all I've got for you today. So I appreciate you watching this engineering overview on how I designed this robot. It's kind of long, but I hope you enjoyed it, and I hope you have a fantastic day. I'll see you in the next one.